Hi, my name is Jason Nisar.
Lucas McCurley.
We are 2013 graduation class of Process Automation in Bachelor of Technology. This is our technical report. We have taken this opportunity to control a radio control car using a smart device. And one of the reasons why we chose this idea is we're seeing more and more integration of smart devices in different applications, and we wanted to take this learning opportunity to take one of the applications and learn. So the hardware for our TR includes the smart device, which for which we have developed the HMI. We have a control box where you have the stock radio controller for the car, which is radio frequency, and then you have the downlink microcontroller, and you have the uplink receiver, radio frequency receiver, and then you have the server where all the software is processed, and then you have the car itself, which has the ultrasonic sensor mounted on it for control for collision detection control, and then you have the uplink microcontroller, and finally you have the radio frequency transmitter for uplink.
Hey, so I'm going to talk about the software and what went into building this project. So you can see this is the HMI on the phone. So this actually was programmed to be have a joystick that the user can kind of scroll around with. So if he wants to go forward, right, back, left. Up in this section is where you would connect to the laptop, so you could send your information. And then right here is where we had the warning display if there was something in front of the object. So the first class that we wrote was the server, and this is what needed to happen here was build the TCP connection, start the service, stop the service, connect, and then be able to send the data and receive data. We also needed to make sure that there was a way that when the DHCP router assigned an address that we didn't hard code that address value. So this server actually uses something called Bonjour, which will basically let us know what IP address and what port is being assigned by the DHCP. So then you don't have to hard code it, and just makes it a lot easier. And then you just have your main view controller, which will be basically everything running on the HMI. So we have things like a status, different buttons they can click, different labels. Of course, we have the server. So the very first method is just initializing, making sure that you're publishing the same browser name. So it doesn't matter what device. Like if there's many devices on the network, it'll know that this phone is called Tech Report Tigris, and it'll be able to connect to it. This is where we sent the data. All we're doing is encoding it into this UTF-8 format, and then it's handled by the server from here. This is where it's going to receive the data, show a warning status on the HMI, and then put the user back into idle so they can't go forward. This is how we set up the joystick to be able to go left, right, forward, and all the motions. Connecting to the service. All this code here is basically talking about updating the table so you can connect to the laptop. Hey, so in this video what I want to explain is what's on the car and microcontroller. So basically there's an ultrasonic sensor that needs to ping and see how far an object is away from it. So you define these two pins, the trigger and the echo, and you measure the distance by sending out a pulse, like sending out the ultrasonic information, the signal, and wait and capturing how long it's going to take for you to get back, and then you can calculate the distance from that. And all we're doing here is creating a long value that's going to measure the distance, convert it into a string, so I'll be able to parse out any unwanted information, and then send if it's an S if something's in the way, or an X if something's not in the way. I'm going to talk about the PC microcontroller. This microcontroller has to do two jobs. The first job is collect information off of the laptop, as well as collect information from the transmitter on the car, telling the car when to stop. So the first thing is controlling it from the laptop. So we need to be able to handle right, left, backward, and forward. So these are the pins that are being assigned, 8, 9, 10, and 12. Pin 11 is actually being used for the receiver pin. We use this thing called virtual wire that creates the connection using software, and you just include the two header files for that. So this actually has three methods involved, and that's parse position, position control, as well as doing a pulse. So if you want to get information off the laptop, you need to first see if the user hit a forward, right, left, back. So we use this coding scheme to come in as a F, R, L, B, 1, 2, 3, 4, or an I. And then while it's in this piece of software, we want to make sure that the user can understand what's going on with the words forward, right. And all it's doing is it's turning certain pins off. If it's let's say forward left, it's going to turn off the pin for forward. It's going to turn on the pin for forward, turn on the pin for left, and then make sure you turn off the pins for the other ones.
So I'll talk about the process now, the overall process. So what happens is the user the user inputs a command from the HMI. That command is then sent to the server. The server processes the command and then sends it to the downlink microcontroller. The downlink microcontroller then controls the stock radio controller of the car, which then moves the car. Now, while the car is moving and the ultrasonic sensor detects an object in front of it, that information is then sent from the sensor to the uplink microcontroller, which then sends that processes that information and sends it to the uplink radio frequency transmitter, which is received to its corresponding radio frequency receiver, which then sends the information up to the uplink microcontroller, which sends the information to the server to process, and the HMI for the user. That information is processed, sent back to the downlink microcontroller, which then shuts off the power to the forward motion of the car as collision detection, and then pulses the reverse to break the momentum. So this entire process of downlink and uplink that I just talked about happens every millisecond. So this is the demonstration of the downlink control using our iPhone HMI controlling the car. So I'll give you a bit of a demo. You can see forward, you can see reverse, you can see forward left, forward right, reverse right, and reverse left. So I'll just show it to you working actually. So you can see forward, reverse, forward left, forward right, reverse left, and then reverse right. So this is the demonstration of the uplink control of the car, where the ultrasonic sensor right there will sense an object in front of the car and cut off the power to the forward and pulse reverse to break the momentum of the car. So I'll show you. See, I'll hit forward. I'll keep the forward on. It didn't hit the object, and I'm going to keep trying to go forward. It's not going to go. And then when I hit reverse, it'll come back.